This building was really the conception of David Fisher as he was creating the new Sustainable Living program. And he wanted a building that would completely honor sustainable living, which is to say that it would be built of local materials as much as possible, built with an extremely low carbon footprint, would be made of natural materials, would be a building that would teach the students, that there would actually be things about the physical structure of the building that could be used to teach sustainable living to the students. And that would also demonstrate the unity of environmental design, energy efficient design, and Maharishi Vastu. And then the design of the building was something that I created with David 7 years ago when there were just a handful of students in the program and I had no idea if this was really going to happen. But David was so committed to it. And then a fantastic team of people joined in the design, and most notably a firm called Innovative Design, who specialize in high performance buildings, who did the construction drawings and engineering for the building. And Dal Loisel and Tim Messenger, who were the construction managers, and also Roel Gunderson, who was responsible for one particular unique element of this building that I'll talk about. And finally, Lonnie Gamble, who is the #2 professor in the program here and who's our great beloved authority on photovoltaic and energy efficient design. The design that David and I came up with initially then got overlaid by a series of bodies of information that we learned or were inspired by from speakers at successive eco-fairs that were organized by students here. The first was when Mike Nicholas, who is the principal of the firm Innovative Design, spoke about daylighting buildings. And I'd known about daylighting and I'd understood the benefits of it, that it greatly reduces the amount of electricity needed to operate a building and also creates greatly superior environment in which to study or live one's life, that educational outcomes improve in schools that have daylighting, and business is more productive in businesses that are daylit, and even Walmarts that are daylit sell more merchandise. So people just seem to be more successful at doing what they are attempting to do if they are within a more of nature's own environment, which includes illumination directly by the sun. So of course I knew this and I'd learned the principles in school and practiced it to some degree, but Mike has really made his career focused on daylighting buildings, and he was very inspiring. And so under his inspiration, I attempted to design this building such that it would be completely daylit. And we were successful. When the sun is out on any bright day, all of the rooms in this building get enough daylight in them that you don't have to have lights on. And all of the classrooms are lit by sunlight from multiple directions, 2 directions, so that you don't have shadows cast on your desk by your computer or your hand, which makes for a better learning environment. So that was the first impact on the design from one of our eco-fairs, which was that Mike had come to speak and inspired us to create something that would be daylit. And then the second was a speaker who talked about building buildings of earth blocks from local earth. And it was something that really caught the attention of the students. And then the construction drawings of this building were created such that it was assumed that the walls would almost entirely be made of blocks of earth compressed from the site. And directly across the street, we had a couple of years before begun a building for a small new commercial kitchen for the university. And then we stopped that project just after we had cleared the site, because Maharishi, in a conversation with Dr. Bevan Morris, the president of the university, suggested to him that this was the time to build a larger building, the first really important major building on the campus. And so therefore the idea was that rather than just building a little kitchen and then gradually as we raise the money building dining halls connected to it, small ones, that we go for the whole thing, that we build our kitchen, we build enough dining space for the university in an expanded condition and incorporate a new student union into the same building and a large auditorium and put it on the most prominent location in the university appropriate to its largest building. And so we abandoned the location where we had begun to build the commercial kitchen and built then the Argiro Student Center directly to the south of it. But we had cleared the site and pushed dirt into a pile. And this fellow who came to MUM to speak about earth block construction looked at that pile of dirt and said, this dirt is absolutely perfect for earth block construction. It has exactly the right amount of clay in it. And so we rented a pneumatic earth block pressing machine from a company in Wisconsin. It was here for a summer. And students stayed over the summer and operated the machine and made about 25,000 earth blocks, which then were stored in the shed for a couple of years and which became this building. So the building is really almost entirely constructed of the earth from across the street, which is, to me, is a kind of profound and moving thing. What could be more sustainable than building a building of the materials of the place? And my own experience is that something else came from that, which is, and as a footnote, another speaker spoke about earth plasters. And so these blocks were then plastered with earth from the site, because again, with high clay content, the earth could be easily, with just a couple of things added, cow manure or straw, could become a really good base plaster. And so all the walls of this building then were plastered with locally created plaster. What we see on the surface, the white, is not that, but we'll see examples of it in one room, which is why I wanted these rooms to be unlocked for you. Because the finish coat we wanted to be very white, because for a daylit building, we have to bounce sunlight around to make the rooms as bright as possible. So we needed a really white clay. It turns out that there's a clay in Georgia, which is very white, a company called American Clay Plaster. So the finished plaster on these walls is Georgia clay, as sold to us in a powdered form by this company, American Clay Plaster. As a consequence, almost all of the wall material in this building is earth or clay. And my own experience over my lifetime, when I have been in buildings that were made of stone or made of earth, such as hundreds of year old homes that I've been in the Middle East, or buildings in New Mexico, for instance, made of adobe, is that there's a different feeling inside of these buildings than in conventional wood frame, typical American houses. Wood frame houses are not so solid, and they actually have hollow walls, even if those walls are filled with insulation. And my own experience throughout my life has been that I feel a kind of solidity, and we could say sort of groundingness, when I'm in buildings that have thick, solid earth walls. And I like it. The effect on me of being in buildings in which I'm surrounded by that kind of material is very good for me. And I feel that very pronouncedly in this building. And I think that it will be good for education, good for learning, to have that kind of solidity on a level of psychology, on a level of, on a real level in this environment. And then at another eco-fair, a wonderful architect from Wisconsin named Roel Gunderson spoke in a very passionate way about his life's work, which is to build buildings primarily using trees, that is, building of wood, but keeping the trunk of the tree as the trunk of a tree. And he speaks about the advantages of this. One is that the wood is much stronger structurally. Trees grow as concentric rings of new growth each year. And each of these rings has a certain amount of structural strength. And when you slice a trunk of a tree to make a 2x4 or a 2x6, you lose the particular geometric strength of the circle, of the way that it grew, as kind of tension rings. And so wood becomes structurally more efficient when it remains in the shape of the cylinder in which it grew. And also it's beautiful, and also it is truly natural. And so immediately Del Loisel had the inspiration that Roll should be invited to design some elements of this building. And my thought then was that this central corridor that we are standing in should be lined by tree trunks, which then could become really structural, not ornamental, because the high roof over this central corridor, which is lifted up above the roof of the rest of the building so that we can have clear-story lights, windows high, that bring sunlight in from the south and from the north into the very heart of the building. That the roof that allows that to happen, the high roof, be completely supported by these tree trunks. And so we are now in a promenade, an arcade, lined by tree trunks. The trees were harvested sustainably from a forest in Wisconsin that Raul monitors. He tracks every tree in the forest that's potentially usable. And when he gets a job in, then he goes through his database and he knows which are the appropriate trees to be harvested and used for this purpose. So he picked the right trees out and harvested them and brought them here and did the heavy timber construction, which is quite specialized and was once the common trade of carpenters hundreds of years ago, but now is a fairly esoteric trade, to fit together round cylindrical pieces of wood to each other, and did the structure for the whole center of the building supporting the roof. And a thought that I had when I considered having tree trunks here was that at the very heart of every Vastu building, like in the heart of all the structures of nature, is a silent point. We call this in Sanskrit Brahmastan, the place where the wholeness of the thing is established. There is a central point that contains the intelligence of the structure in galaxies, in solar systems, in physiology, in molecules, in cells, and atoms. And that's a pattern which has a particular function in nature. It maintains the link between that isolated structure and the rest of the cosmos. It is its link to infinity. And when we create structures that are to be in harmony with nature, we should also give them that central point, which should then be set aside. There should be no activity on it. And it should be daylit. It should be flooded by light directly from the sun. And so we're standing now in the Brahmastan of this building, and the vision that I had, and in time we hope that there will be a large amount of plants growing on this cube. There are particular plants which are ideal for it, and that will be one of the tasks of the students, to grow those plants and keep them here, and so it'll be more kind of living at that time. But the idea that I conceived of was that this is a building which marries the most profound and cosmic understanding of architecture in accord with natural law, Maharishi Vastu, and sustainable living, energy-efficient design, and which is also architecture in harmony with natural law. And so my idea was that at the heart of the building, that where we have this pattern from Vastu of the Brahmastan, nature with a small n should also be very present. And by lining this space with really 8 trees, 8 tree trunks, reaching up 6 or 7 meters into the air, that we have created a grove of trees, a copse, a little piece of nature in the center of a building. And so you can have the experience of being among trees with sunlight trickling in above you in that kind of soft, indirect way that is your experience when you're in a grove of trees, when you're in a forest, which you do not normally experience when you're in a building. And in that way, at the heart of this building, to dissolve the artificial distinction between the manufactured world and the natural world as an inspiration to students of sustainable living to appreciate that they can really achieve what is their own aspiration during their years of study here. Let me show you a couple of things in here. At the moment, this room is being used during this course. Students are using microscopes in this room, and so the natural light is actually too intense. And so the windows are temporarily shaded. In this room, we left one wall with the natural earth plaster on it. This is the plaster which is made of soil from this location, mixed with cow dung and straw, and troweled on by hand. And it feels wonderful. There's actually another effect of using clay plaster. If you have thick enough clay plaster, according to studies, about an inch or so will begin to do this. Clay is hygroscopic, which means that it absorbs vapor out of the air and also puts it back into the air when the relative humidity is higher or lower. And so during the summer, when we suffer from high humidity, it's a little uncomfortable to us. Thick clay walls will absorb, soak up the vapor in the air in the building, reducing the relative humidity in the building. And in the wintertime, when air is naturally dry, the walls then act as a bank, sending that vapor back into the air and naturally raising the humidity level in the walls. And we have extremes of temperature and humidity here which make this challenging. It's an experiment, but in parts of Northern Europe where the extremes of humidity and temperature are not so great, this is the sole means of humidification and dehumidification, air conditioning, which has been used successfully in many, many houses. So we're giving it a try. And continuing with the notion of a building that teaches, in this room, we left some of the clay blocks exposed, whereas in the last room, we left some of the raw clay base plaster exposed. In this room, the entire west wall and also a band of blocks on two of the other walls are the earth blocks themselves. And so you can touch them, you can see them. They're dry laid, that is, there's no mortar between them. This is a room which best illustrates how daylighting works. If you have a window into a room at a conventional height of a window, as we have 3 on the north wall of this room, a window throws sunlight in at a certain angle, and a window of a conventional size and height only throws in sunlight which is bright enough to read a book by about 15 or 20 feet into a room. So if a room is larger, you can't daylight using conventional windows. So we do 2 things. First of all, we have higher windows because then the sunlight coming in at that same angle will go that much further into the room. Second, we have more glass up there to bring more light in. But anyone who's ever sat at a desk and held a piece of paper or a pencil in one hand, which we may not do so much anymore, knows that we cast a shadow, and it can be very difficult to try to work on paper when light is coming strongly from one direction. And so to have a good work situation, we need to have light from more than one direction. And so by raising up the roof at the center of the building and lining the north and south walls of that roof, of that piece of construction with glass, and bringing light in, and then something that Mike added to the design, Mike Nicholas, is trays that help to bounce that light in through these openings in the wall. We have plenty of sunlight coming in from a second direction, which is also bounced in further through the irregular shape of the ceiling in this room, so that even at the very middle of this room, even at the desks which are as far as they can be from the outside walls, there are sufficient foot candles on the desk that a person can read and study. So these are the principles of daylighting, and this building applied them, and they work.
And at night, what do you do?
At night, you turn lights on.
Okay.
And in this building, the lights are in little 2-foot by 4-foot panels, which are called troffers, and they look sort of vaguely in our mind's eye like conventional fluorescent troffers that we see in most commercial or educational buildings. But in fact, these are LED lights, light-emitting diodes, which environmentally are much superior, and the quality of the light we consider to be superior, and which have reduced electromagnetic radiation. And so in 3 counts, they are superior. They also last frequently for 20 years. The bulbs are, at this point in time, still rather more expensive than fluorescent lights. But when you calculate their cost over the course of their life, they are vastly cheaper. And the power for them is provided through battery storage, which batteries are charged by photovoltaic electric panels on the roof of this building and on its annex, and by a wind generator. And so while this building at this point in time is hooked up to the electric grid, it almost never in the course of its life will actually need to take any electricity from the electric grid. Typically, in these first weeks of its operation, at any given point in time, it has, while the sun is out, it has been generating between 5 and 50 times as much electricity as it has been using. And the rest of the electricity that it's using is going to power the other buildings on the MUM campus. Now, this is not only very good environmentalism, this is very sustainable living, but it's also a great economy for the university, because the electric company here sets its electric rate for large customers based upon the single hour in the entire year when they use the most electricity, which is typically mid-afternoon or late afternoon on a day in August when everybody has their air conditioning on maximally. When it's super hot, that means the sun is out. That means that this building is generating maximum of electricity, and it is supplying that electricity to our internal university grid, reducing the amount of electricity that the university is using, and therefore lowering the amount of electricity that it is using during its peak hour in the year, saving the university money year-round by lowering its hourly rate. So in a very nice circumstance, the environmental benefit is equally a direct, immediate economic benefit to the university of building this building. Electric solar panels have loomed very important in Maharishi's own vision of sustainable living for a very long time. The first talk that I heard him give on this subject of architecture in accord with natural law, he made about 10 points. And one of those points was that we should get our electricity directly from the sun. He was proposing photovoltaics. And this was so important to him, unusual as it was in the mid-1980s, that he had our organization found a factory in India to make photovoltaic panels, and we continue to today. This is a very quiet building. It's not always absolutely silent. When we do need to have fans go on, rather than having them run all of the time or run all of the time when classes are in session, they run maximal efficiency, because in all of the classrooms there are little sensors mounted on the wall which are measuring the level of carbon dioxide in the atmosphere. As we respirate, we give off carbon dioxide. And when it reaches a certain level, that says to the machinery that we need fresh air. And so if you would like to stand up and breathe on, yeah, breathe into that. Just sort of exhale for about a minute. Just start breathing on it. Exhale with some volume. And within about a minute, we're going to hear a gentle fan come on, and it will start to provide fresh air just to this room.
There it goes. Good work, Jay.
Yeah.
It responded to you.
Thank you. The windows are extremely thermally efficient. They are the most thermally efficient windows made in the US, at least at the time that we ordered them, with an R of 10, which is to say that this is a measurement of how much heat can pass out through them. And windows traditionally would have double-glazed windows might traditionally have an R of about 2, and a really good window with a vacuum and argon gas in it and a film, really good one might have an R of 5. These have an R of 10, and so they are, we could say, twice as energy efficient as a conventional window. The east and the west, we have a problem. And the problem is that the sun rises in the east, it sets in the west, and it's on, depending on the time of the year, it goes up in the sky at an angle. It might be like this, it might be like that, which means that late morning and mid-afternoon, sunlight is coming in through east and west windows. Now, late morning and particularly early mid-afternoon, there's a lot of solar heat gain in sunlight, but the sun's relatively low in the sky. And that means that to shade those windows, the shades would have to extend out maybe 8 feet away from the window to cast enough shade in the summertime to shade the windows. And nobody builds shades that are 8 feet long. It turns out that there's a pattern in Vastu, which is to have a veranda on the east and west side of a building. We don't build many Maharishi Vastu buildings with these verandas. I've designed many. They usually get cut out because they're not an essential part of the functioning part of the space, and they cost money. And so often, if enough money hasn't been raised, they're eliminated. But interestingly enough, the two buildings that are next door to us to the north, the Peace Palaces, which were built absolutely according to Maharishi's design under conditions where every penny counted, he absolutely refused to let the verandas be eliminated. And even those buildings were built very, very cheaply, and we hope they hold up. They have the verandas because they were so important to him. It turns out that a veranda shades a window extending out about 8 feet or so, which means that once the sun gets a little bit higher in the sky in the east, it's no longer casting direct light through a window. And in the afternoon, it's only near sunset that it is casting direct light into a window. And therefore, if a building has verandas, which is a really good Vastu pattern, then you don't have solar heat gain on the east and the west. And so we now know how to deal with the windows on each of the 4 sides of a building. If we were to build verandas, we've taken care of east and west. And so I designed verandas on the east and west side of this building. We haven't raised enough money. The west verandas have not been built yet. The east veranda is greatly reduced, and part of it is a sort of trellis, and we have in the plan another $30,000 to be raised, and then the verandas will go in, and then that Vastu pattern will be completely fulfilled. The benefit of east light, it is ideal to get sunlight from all directions into a building, as this and most buildings do. There's a particular benefit to east light. That benefit occurs around sunrise. And so what is particularly important in a building is not to block the early morning sunlight. And so the verandas do not block it, and so it's okay. The key light for illumination is north and south light. The reasons are because south light is much more intense in the northern hemisphere because the sun spends when it's higher in the sky, which when the sun is higher in the sky, sunlight is passing more directly through the atmosphere. It's filtered less by atmosphere, and so more of the sunlight hits you. So sunlight, when the sun is higher in the sky, is brighter. We all experience that, but that's the reason why. For daylighting a building, the most valuable light is south light, but also, paradoxically, north light. North light, as many of you know, is highly valued because it's even light. And so to daylight a building, it's ideal to have as much north and south light as possible in it. There are several things that we have as goals for this building which we have not yet executed. And we have as an intention that the water used in this building will be completely supplied by rainwater, which is stored in rainwater catchment. And we also have the intent that we will process all the sewage generated in this building on site, and the water that leaves this building will be completely clean. And neither of those two technologies, which are not a big deal and which have been widely done, and certainly rainwater catchment is the primary source of water in much of the world, we haven't executed yet. We have more money to raise. We have budget amounts for each of those, and when somebody makes those donations, then those will be carried out. So thank you very much for coming. It was nice to share it with you.